So here are 3 examples of composing functions. F of g of x, you just simply take the g of x and you put it inside the f function, which is what we did here at first. This goes inside the f function and replaces the x. Boom. And so on and so forth. Now this here is not simplified. Of course, you could just get rid of the brackets and you have this. This, if you were simplifying, would be 4x plus 24 and so on. Okay, so that's your new function. All right, so what I'm going to do now is I'm going to go from here and we're going to do some examples where we actually put an input value into the inner function. Okay, so I'm going to start to erase just some things here. Okay, and I want you to see how this works. So what if I asked you for f of g of 2? F of g of 2. Now I'm asking you for an actual real number answer. Okay, so you still start with the inner function and you go g of 2. Well, g of 2 is actually 2 plus 6 or 8. Right? So now 8 goes in, oops, where am I going? Goes in here. Okay? I eventually got there, but this whole thing becomes 8. I'm still trying to work with this here. So the 2 is there. See? And here is 8. And so it's actually this. 4 times 2 is 8 plus 24. That's your end result. So that might be a little confusing now. Let me go back up. You can write like that if you want. But this is what you're going to end up doing. You're going to end up evaluating g of 2. Say, hey, that's 8. So I'm going to rewrite that as f of 8. See that? Now f of 8, you go over to the f function, and you say 4 times 8. Right? Is what? 32. So there is your answer. F of g of 2. The output variable of 1 becomes the input variable of the other one. Okay? So I'll erase all these now. And we'll try g of h of, I don't know, 3? Let's go wild here. H of 3. Oh, not 13. Okay? I tell you what, why don't you guys do it? And I'll reveal the answer in a few seconds. Okay, so did I do that right? Yes? Does that agree with you? Okay, let's go back and see what we did. We put in 3 in for the h function, which over here means that becomes 3 squared is 9. So I put 9 right here into the g function, which is right here. So 9 plus 6, 15. Good? Easy, right? Easy. Totally easy. Like way too easy. Baby stuff. Okay. So let's try here. Let's go, I don't know, 31. Good luck with that one. H of 31. Go. All right, so the answer is 923,521. How many of you needed a calculator for that? Shame on you. Just kidding. I did too. All right, so h of 31. 31 squared, 961. Put 961 now into h again, and you get 961 squared, which is 923,521. This is so relieving after so many graphs. Really, you like this stuff? Yeah, this is pretty easy, eh? Okay, let's move to some graphs now. What? I'm just kidding. This would be easy for a giraffe. For a giraffe? I just said giraffe. I meant graph. Graph and giraffe are pretty close, right? That's pretty close. Actually, math probably would be more interesting if I called every graph a giraffe, right? Okay, get your giraffe paper out now. Wouldn't that be more interesting, the giraffe paper? We're going to draw a giraffe of the function now. You're not impressed. I can tell. It's like, Maxwell, just get to work. Okay, sorry. Sorry for the moment of levity. Apologize. Please delete that from your memory. Okay. Ooh. Oh, yes. This is good. Okay. Are you ready? H of x is x minus 2 squared plus x minus 2 plus 1. Now, I am telling you that h of x is composed of two other functions. Name the two other functions. F of x equals g of x equals. Ooh, so now we're going backwards. Are you wanting giraffes back? No, still not? Okay, good. Good. All right, so what's the inside function? What's the outside function? Go. Okay, so this is my hint, but obviously you're still struggling with this. Okay, put up your hand if you have no idea what's going on. Wow, that's a lot of hands. Okay. All right. Remember, you're looking for a function. Okay. Hey, quiet, listen. Be prepared to be amazed. A function inside another function. A function inside another function. Look at this. This is a little baby function. It is inside the big mother function. Don't say that real fast to your friends on the street. Check out this mother function! I'm just saying. You might not want to do that. Especially if you yell it really loud with like a, what? Did they record that? Why not? I'm just telling you what to do. No one should say that, okay? All right. All right. Odor in the court. Odor in the court. It's the boys in the back. The boys in the back. Yeah. Do you know it's like what the judge said when the skunk came into the courtroom? Okay, forget it. Oh, is it order? Thank you for correcting me. It wasn't a joke. It wasn't a joke. Okay, we need to finish this. Hey, we need to finish this, okay? Listen, the dozens of YouTube listeners across the world are still waiting for me to finish this, okay? My loyal 14 subscribers are upset here now, okay? Okay, yeah, I know you're all here in class. Okay, shut up! Okay. Okay, I'm going to talk quiet so you guys stop. Okay. The little baby function is x minus 2. That's the baby function. Okay, back to math. Now, here's the tricky part. Now what you have to do is you have to basically say, okay, that's the little function. Let's think about what the bigger function is without this.
But what if it was two different functions?
If this was different than that, then this is not what it is then. Let's just get through this example first, okay? Let's just get through this example first. Now look at, this is now the larger function f of x right here. So it's x squared plus x plus 1. There's your answer. Okay, here's the second example. Second example. All right, so I want you to do this. Find f of x and g of x, where g of x is inside f of x, or f is composed with g. Okay, another way to write that, f circle g of x. So g is inside f.
Wait, what is the circle?
Label g and label f. Yes, it looks like fog. Thank you. That's good. Very good. Very good. Fog. Yes, fog. Thank you. Very good. No, that's important. Yeah. Students every year I've taught this have noticed that this looks like fog. Okay? And here's just another opportunity for you to be distracted. Okay, congratulations. It's not an O. It's not an O. It's a circle. Why is it a circle? I don't know. Why does your name start with this symbol? I don't know. No, the answer is the same. Why? I don't know. That's the notation. This means S. That means composed with. Inside function is inside something else. So g of x, right, which is what the inside function is x squared plus 1. F of x, the larger function here, is root x. Now, it may help, guys, listen. It may help if you think of it this way. These are my two functions. What is this? You put g inside of f, and you get root x squared plus 1. Okay? So it all works together. Okay, baby function inside the larger mother function. Just remember that. You're not going to forget that now. Mother function. In your textbook, you have an example here of a function within a function. So in this one here, this is on page, I don't know, page 506-ish. And here you have a function a volume function for a sphere. And inside the function goes another function, root t. Okay? And so the formula for the volume of a sphere is this. And since r is a function of t, we can compose the two functions. So there's an example of another function going inside another function. Now, upon simplification, let me zoom in here. Okay? When you simplify, remember root t can be written as t to the power of 1/2. And so when that happens, you multiply the exponents there, and this is your simplified version. Okay, so remember to simplify when you can. I didn't simplify for my first few examples just so that you could kind of see how it goes, but make sure you simplify. Okay, so actually I'm going to leave you with the key ideas. Oh, this is really big. I'm going to leave you the key ideas here to take a look over, and I'm going to give you your assignment. Any questions? Done. Okay, just kidding. We're not done. Just watch number 2. I'm going to show you how to do number 2 because this is the dreaded giraffe question. It's not hard though. Watch. Listen. G of -4. Here's g of x. If we go to -4, what's the value of g of x at -4? 0. That means that 0 goes in for the f function. So now you say, what is f of 0? You go to the f function. F of 0 is 2. You look at the giraffe. Okay, let's do B. Look at g of 0. What's g of 0? Let's go to 0. Let's go to g. -4. So I put in -4 into the f function. Well, go to -4, and it's up to 2. B is 2.